Okay, today we're going to look at qualitative analysis. So under mole concept, we have learned about quantitative analysis, like how much of the substance there is. Okay, in qualitative, we are not interested in that. We are only interested in whether a substance is present or not. Okay, so in our first lesson, we're going to learn about deducing of cations present in a salt solution. So cations we know refers to positive ion. Okay, and we're going to learn about anions later, which refers to the negative ions. So once we know the negative and the positive ions, okay, we would already have mastered this topic. Okay, so what exactly is qualitative analysis? So qualitative analysis is to identify whether a substance is present or not. Okay, for example, if you have iron 2 plus, we want to determine whether it's present or not. Okay, or Ca2 plus, we want to determine whether it's present or not in the solution. Okay, whereas for quantitative, we actually want to find out how much substance is present. Like for example, how much Fe2 plus is present. Okay, so we are not interested in this topic that was under mole concept. Okay, we are interested in qualitative analysis, whether the substance is present or not. So when we do qualitative analysis of cations or the positive ions, okay, when we look at a solution, most of the time it is colorless. So we want to determine whether what ions are present inside. We cannot just look at the solution and try to deduce. So we need to add some stuff inside. So if we have an unknown salt solution like this, colorless, we want to determine what is inside. Okay, we need to add two solutions. One of them is sodium hydroxide. Okay, and the other is aqueous ammonia, or some people call ammonium hydroxide. Basically, they're the same. Okay, both of them are what they have in common. They are both alkalis and they have OH minus ions. Okay, so we're going to make use of the OH minus ions to deduce what positive ions there are inside this solution. Yeah, so what will we do? We will first add a few drops of sodium hydroxide first. Okay, and then we will add excess of it. Then we'll observe what? Two things. Okay, number one, we will observe the color of the precipitate. And then we will observe whether the precipitate can dissolve or cannot dissolve inside excess sodium hydroxide. Okay, so you see in the second step we add excess, right? So we are going to determine whether a precipitate can dissolve or cannot dissolve in excess sodium hydroxide. Okay, so let's take a look at the first part. So you have zinc, lead, and calcium. You will notice that all of them form a white precipitate. Okay, but then when we add excess, okay, only zinc will dissolve in excess and lead also will dissolve in excess to form a colorless solution. Okay, you will see that calcium cannot dissolve in excess, so it's insoluble in excess. So that's how we tell the difference between calcium and lead and zinc. Okay, so zinc and lead will both dissolve in excess, whereas calcium, the precipitate will not dissolve in excess. Okay, next let's take a look at the colored precipitate. So you have copper 2. Copper 2 forms a light blue precipitate. Like remember our copper 2 sulfate crystals. Okay, they are also blue in color. Okay, next you have green precipitate for iron 2. Reddish brown for iron 3. You can think of it being like rust. Remember, rust is iron 3 oxide. Here is iron 3 hydroxide, so they have the similar properties. Okay, both are reddish brown. Then the last one for ammonium, it does not give any precipitate. Okay, but for ammonium, remember when you have ammonium salt plus alkali, which in this case is sodium hydroxide, it will give us salt plus water plus ammonia gas. Okay, so because it produces ammonia gas, so you can see we can test for ammonia gas here. Okay, so ammonia gas is given off, it will turn moist red litmus paper blue. Okay, why do you need to make it moist? Because ammonia gas needs to dissolve in the water to be able to turn the red litmus paper blue. Okay, on excess, we don't see any change. So I'll stop here for now. We will continue the rest with aqueous ammonia in a later slide.